My name is Sanjana and my project is on textile dye pollution. Water pollution is one of the leading causes for water scarcity in the world. The textile dyeing industry itself causes over 20% of water pollution. I have personally seen colorful rivers full of these dyes in India, and I wanted to see if there was a way that I could protect our environment. Degrading these dyes is a huge step forward to protecting our environment. Unfortunately, the traditional chlorine and heavy metal-based oxidation of these dyes makes the problem worse because they leave behind toxic byproducts. Green oxidation chemistry can save the day. Green oxidation chemistry uses oxygen or hydrogen peroxide in order to degrade substances. It also only leaves behind harmless byproducts such as water and oxygen. I decided to use hydrogen peroxide because it is a more reactive substance and it is more efficient to use. Even then, we still needed to create a catalyst in order to activate the hydrogen peroxide. I decided to use an iron-based catalyst because it is abundant in our bodies in the form of hemoglobin and cytochrome P450. I worked with Dr. Ghosh at the chemistry labs at UALR. So first what I did was I synthesized a ligand through multiple steps, and I added N-butyl lithium and ferrous chloride to my ligand to create my final iron catalyst. I then degraded the dyes indigo, carmine, and orange 4 using the iron catalyst and hydrogen peroxide. I found the percent degradation of the dyes using a UV visual spectrometer, and I found that the indigo carmine dye degraded 99% and the orange 4 dye degraded 82%. Overall, I found that green oxidation chemistry is a better process to be used than chlorine-based chemical oxidation, and large-scale application of this process can substantially decrease water pollution in the world. And water pollution, this process can be implemented right now. It's not a process that we have to wait until the future to use. It's something that we can use right now to solve our environmental problems. Now I'm going to show my poster board. So over here are the steps that I used to synthesize my ligand. And here are a few pictures that I took while I was synthesizing my ligand, and you can see several of the processes that I used. And after that, this is one of the samples that I used of indigo carmine, and one of the reasons I used indigo carmine and orange 4 was because they're both very prominent in the textile dye industry. As you can see in these pictures, both the dyes degraded very prominently. As you can see that they're way clearer than they were before. And then while using the visual spectrometer, I found the percent degradations of both the dyes, which were 82% for orange 4 and 99% for the indigo carmine dyes. Thank you.